All right, hello everybody. So I'm back again, and this time I wanted to talk about some spanning tree issues I've seen, and more specifically, I've seen this with Juniper switches and Nexus 7, it's mostly 7000s, but you could get this with a 5000 or a 9000, basically anything supporting virtual port channel. And where I've seen this is, especially recently, I saw this in a network where we had this topology. So let's make life easier, and I'll explain everything in great detail. What we have up here are two stack sets of Juniper EX 4200 series switches. And so each pair is stacked, and they are connected with a port channel, and all VLANs are allowed. And the Nexus 7K, and just as a note, yes, I know I did not populate anything in this Visio stencil. It was too much time, and I'd rather focus on engineering than making it look too pretty. So, without further ado, to get that one out of the way so no one points out that I didn't populate anything, because it doesn't matter. Ports are ports, as far as we're concerned here. Assuming they're all, let's just assume they're all 10 gig, and that reality is these two are actually connected here, but neither here or there. So let's talk about this. Let's start at the top. We have two Juniper EX 4200s, once again, stacked, connected together. And what we have is we initially tried a couple of different variations. Now, one, we do have a problem. And I want to point this out, and I want to point this out very, very clearly, because there's a lot of confusion I've seen going around the internet, and it's because no one's placing emphasis on the port type. When we talk about interoperability between Cisco Nexus running rapid-pvst and Juniper switches running rapid spanning tree protocol. Now, the difference obviously being is that Cisco follows in lockstep with the RFC, in which that it's rapid, but it's one instance for all VLANs, and Cisco is rapid per VLAN spanning tree. So, and there is some, there is some variations on, especially on the layer 2 multicasting. But on an access port, so a port at which we are not tagging traffic, it is going out untagged. It's just that the port VLAN ID is in that specific VLAN. If this connection here and here were an access port, and it were, I don't know, VLAN 100 from here and here, well, we wouldn't do anything special at all. It just works. But on tagged, so in the Cisco world, trunked, also known as tagged interfaces, on tagged 802.1q interfaces, we will have a problem. If you leave it to default devices, in which Juniper at rapid spanning tree protocol, Cisco NXOS rapid per VLAN spanning tree protocol, you will have problems. You'll have a loop, and most likely you'll fall into root port inconsistency depending on how your network is configured. So initially, the first thought is, well, let's just run MST, because MST is, NXOS calculates the hash using post standard, so the EX series switches. Well, so when you have your instance to VLAN mappings exactly the same, and there's the same number of VLANs exist on the Nexus as do the Junipers, and they are mapped all accordingly in the same instance, your configuration name is spitting this image the same, and your revision is exactly the same. You've made sure everything is so the same, and by nature, and by the way it's supposed to work, using the same hashing algorithm, they should all calculate the exact same hash to form the same exact MST region. That didn't happen. And my experience with this recently was on a set of 5548 UP switches. And I haven't tested this with 7Ks, but I figured that for the most part, let's just assume that this is what your environment will look like. But for what it's worth, these could be 5Ks, 9Ks, 7Ks, 6Ks, 3Ks, whatever. And that was confusing. I mean, we poured through everything, and everything was exactly the way it should have been, but the hashes were different. Thus, no matter what, we found ourselves with boundary ports, which is fine. Boundary ports are okay. It just means you have two different regions, and that's fine usually. But we kept running into some strange issue with, once again, root port inconsistencies, and it completely unexplainable, other than that there's, Juniper it involves a different, I dare I say VLAN 0. I'm not as up to date on my Juniper stuff as I used to be, but we factored in that's the only thing that could be causing this. We did everything. We made sure everything was right. We actually made sure that every single thing was the way it's supposed to be, and it still didn't work. we kept having problems. So the solution that I've come up with is we are going to run at the Junipers. We're going to run, and once again, they're running both VSTP and RSTP for, let's just say there's more Juniper switches dangling off the switch, but we're not going to list those. That's for someone else to talk about. For our case, these tagged links, these port channels going down, and the VLANs associated will run VSTP towards these Nexus 7Ks and a VPC. Now, this is called a hybrid setup, and you can check Cisco documentation right here. 7000 peer switch configuration hybrid, and this is kind of what I'm doing here, but I'm not load balancing. What I'm doing is I am administratively setting things so wildly that there's no chance on God's green earth this could go any other way. So this is a good document to read, but here is why I say avoid this at all costs. For one thing, and I know I'm going to catch flaming. I mean, go ahead, flame away. I got my flame suit on. EX4200s are not core switches, not for an enterprise, definitely not for a data center. I'm going to take this one step further. Fixed port switches are with stacking is a poor choice, is a poor man's choice in a medium to large size enterprise or data center. I'm not going to get into the specifics, but plain and simple, what you're saving in upfront initial investment is not going to pay off in the long run. With chassis, you are going to have numerous power supply. You're going to have more than, hopefully at least, depending on the chassis you purchase, more than 2 power switching units. So you have N+1 redundancy. You're going to have hot swappable fan trays. You're going to have, in the case with the 7000s or 9500s, you're going to have dual redundant supervisors. So you can't, and then on top of that, you can actually have redundant interface line cards, redundant fabric modules. There's redundancy built all over this thing, but you're not going to get that. You're not going to get the same level of redundancy in a core switch with fixed port switches. Plain and simple, it's just not going to happen. It's a poor man's choice, but trust me, your initial low-cost investment up front is not going to pay off in the long run when it comes to the headaches and failures. And I'll say this: when you introduce stacking, let's think about it. Cisco Catalyst stacking, it operates a little differently than Juniper's stacking, which operates differently than 3Com stacking. So you introduce, how at the layer 2 forwarding information, right? How is that distributed? How is that working? And then when it comes to layer 3, what happens there? So there's all these things to consider and take into account that you complicate the mess. The second reason why I'm going to say EX4200s simply are not, other than the obvious fact that they're, well, for one thing, last I checked in the Search Juniper's website, I don't think they're even listed in core. I think they're at access layer. And one thing, PoE in the data center, really don't understand it. So maybe you have phone to run. I don't know. I've never seen the need for a pure data center to have PoE. Never quite understood why a core switch needs to have PoE. I think PoE generally is going to be, we all can agree, mostly for phones and IP cameras, and that's going to be at the access layer. So, but whatever, each their own. The other thing is, I'm going to go ahead and say it. They do not support multi-chassis link aggregation, although I've heard from some sources that they do it. And if it's just 2 switches by themselves, it's okay at best. Introduce stacking, and it's buggy at best, if not downright failure. But it's not an official source. I've heard it from a couple people who've tried it. So once again, and we're talking data center here. I'm not talking about enterprise. In enterprise, this might be fully acceptable, having this type of topology where you have half your basically half your infrastructure dead, waiting in standby. In the data center, look at everyone out there: Cisco with VPC and VSS, and then you have Juniper, Arista, HP. They all have multi-chassis lag, or they've all been working on things like Fabric Path and What's that other promising technology I keep hearing about that seems to never come to fruition? Trill. I've just never really seen it. I've seen it in theory. I just haven't seen it in production. But let's look at it this way, and then finally, what we've all come to now in the data center, especially with VX with SDNs, is and NSX and VXLAN, is that we're doing it in software, and that our communication for spine leaf has no longer layer 2, it's layer 3. And why? Well, layer 3 is just easier, better, and predictable. Especially if you use an open protocol like OSPF or ISIS. You have equal cost multipathing, which is extremely predictable, and you have multiple links, and it's just better. If you understand anything about layer 3, it's just better. So look at how the data center has evolved over time, and you'll see this is just not this is so far from any valid data center design in 2015, going into 2016 in 2 days. So they're just plain and simple. EX48200s aren't, and I'll say the same thing. Catalyst 3750Xs aren't. Cisco Nexus 3064s or 3172s are not core switches. They're not. Any fixed port switch in a medium to large size data center that demands uptime is not a solution. In fact, if when you selected the item and purchased it, you did not pick something out of a core menu, you didn't buy a core switch. So don't be mad when things don't work. And I'm not advocating that, go ahead and swap these things out and put Cisco in there. Ideally, if you've added a pair of Ciscos here, yeah, it makes life easier. It's more uniform. But honestly, so understandably that they do have HSRP running or VRRP running between these guys. So I could see that. They want that first top routing protocol redundancy. But do they need it? I mean, when you think about it, if you wanted to remain cheap, you could collapse this, all 4 stacked together, and you don't need it. You don't need VRP anymore. You just have your links going up, and then you've got redundancy across 4 switches. You could do that. This design just isn't called for anymore. It sucks, and that's just the sad truth about it. In a modern data center that demands considerable ROI and active forwarding to use all the money you've paid for, especially if these are 10 gig links, or new standard becoming 40 gig. So there are other Juniper switches out there. My recommendation is chassis-based ones that do multi-chassis lag. So I really don't recommend. Once again, I don't recommend stacks. I do not recommend stacked switches for anything at the core. To go Juniper, there's plenty of good products at the chassis level that will do multi-chassis lag. And you set that up, and then this is just everything you need it to be. Boom, boom, active. It's all active. Move on. Have a happy blah 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 blah. And as far as spanning tree is concerned, it's a breeze and can be easily set up, and you won't run into these issues. And any other vendor as well. But obviously, if you do Cisco virtual port channel and you put a pair of Ciscos up here, as long as you just conform to the fact that you don't use the same domain ID between the two, it's easy flowing from there. So moving on, the interim solution until these are replaced with proper core switches is we're going to go ahead and designate the A side. So on the left here we have the A side, Juniper A, Nexus A. And on this guy, we're going to run VSTP with the bridge priority for all VLANs to 4096. So the non-root configured for backup operation, also running VSTP, all VLANs set to 8192 on the B switch. Now, when we ignoring everything south, let's take a, we know that this guy's going to be root, so designated forwarding for all ports. Over here, he's going to hear the superior BPDU and go, okay, my path cost to get to you is this direct link, so it's 0 because you're directly connected, and he becomes the root. That becomes the root port, and that's how that works. So moving down, let's get into the Ciscos before we figure out how these port states work out. Well, because we can't do VPC across, we have 2 port channels. Let's just say port channel 1 and 2. Well, so check this out. They have to be orphan ports. So this design sucks to begin with, because now you have to run orphan ports, and orphan ports at best should only be acceptable on on end hosts that don't support LACP or any type of link aggregation or link bonding. So at best, it's good for that, but this is just, in my opinion, unacceptable and should only be used as an interim solution anyways. So it's well documented right here. Port channel is not a VPC. And then, so let's take a look at the configs. Obviously, we have our VPC peer link. We have our management 0 back-to-back. Peer keep alive's happening. These are in a full VPC mode. And let's look at the summary down here. Both switches are in a VPC domain. A peer switch is configured in the VPC config, which does command that the main configuration for rapid-pvst is exactly the same, but the pseudo information is different, and we'll get to that. As we state, rapid-pvst mode is enabled on both switches. Bridge priority for all VLANs is set to the highest known value, 65,536. So there's absolutely no chance these things are ever going to be root unless everything dies. And so for the spanning tree pseudo information, we configure it on both switches. And when we configure this, we're doing it so that we administratively define, no matter what, this switch is going to be the absolute path out. So our A path is fully active and B is blocking. And with that, we come over here, obviously configure your B switch, PVST for a rapid config global. Go into spanning tree pseudo, set your root priority to the second lowest. Remember, lower is better. So 57,344 on root and designated. And obviously, you must set the orphan port suspend on your orphan ports. Oh, and come over to B, so same thing, 65,536, except for we go one up higher, 61,440, 61,440, and orphan port suspend. This way, once this all converges, we know this to be true. He sends out, so this guy's automatically directly connected to the root port, no matter what. So he's gonna have a path cost of 0 right here. So his root port cost of root is 0. So he's gonna have, he just has his cost is 0, and let's just say it increases by 100 right here. So this guy's gonna know. Let's just say this is let's just say it's 100, right? So it comes out and it's, you know, cumulative path out is let's say 110 out this way. So from B to A to up, and or yeah, let's just say it's 50 from B to A to up 50, and let's just say up to here. So we, you know, let's just say this is 110. So this is 110 cumulative out. Well, we know that we can get to root, you know, basically going over the peer link and then going out. So essentially, the peer link. So I guess if I wanted to update this, I don't like. Once again, this is so suboptimal. I hate having to do anything over the peer link that I don't have to do, but this is what you have to do. The root port is here. So on this side, you'll have designated forwarding on A, and he'll be root port right here, and alternate, and then this will be a alternate port blocking, because that's his alternate path to root. And that's how you basically get to this converged. When spanning tree settles, this is how it all ends up. And so to get more detailed information on that, do look at this. It's the pseudo information. It's usually more meant for the load balancing, but I live by the rule that if I can administratively define it, I'm going to. I would rather know how it's going to work by virtue of administrative definition than crossing my fingers and hoping that something works or nothing changes later on. Plus, it's easier to show a customer how it all works, especially with spanning tree pseudo. It gets a little hairy. So this is a great document, and you know it's basic. It's under support. I mean, just Google Nexus 7000 peer switch config hybrid setup, you know, and read through it. It's a great read, and that's kind of about it. So this would be sort of the setup you would run with VSTP. And once again, it's only because in my experience so far that with all values configured exactly the same, you know, VLAN databases hold exactly the same VLAN IDs, and MST instances to VLANs are mapped, configuration name is mapped, it's set, spitting image the same, and your revision's exactly the same. I've just so far have yet to see the hashes be exactly the same. And then because there appears, you know, and then no matter what, we get the root port inconsistency. But with this setup, we actually achieve what we need to achieve. And so the reason for orphan port suspend real quick is that, you know, so this is A active, B passive. without orphan port suspend, if the peer link got cut, so by virtue of virtual port channel, all your southbound stuff, the VPC port channels will die, but not the non-VPC. So this guy still remains up. Now, so when we look at this, because you know he was a designated port going forward, he just cuts, so it doesn't really change anything. But what happens here, right? This guy goes away. B no longer hears from A, the superior BPDU. It's going to hear about it coming from here, and now he becomes root port, and now you have a loop. Potentially, yeah, you have potentially have a loop. Well, not potentially, you do. So, if you cut the VPC peer link and you have orphan port suspend on, and I typoed that. That is so crazy. I'm stupid. If the VPC peer link is cut with orphan port suspend enabled on those interfaces that are orphan ports, in lockstep with shutting down the virtual port channels, it will shut down this orphan port as well in lockstep with it. That way you prevent a routing loop, or a layer 2 loop, excuse me. But it's also good for when you're doing upgrades as well. So when you shut something down, everything is proper, especially if by chance you reloaded the primary before VPC member before not the secondary first, then you know, things can, you have continuous forwarding that way while it takes over and does its calculations real quick. And obviously with your peer link, you know, you want to set for a design like this, I would really set your rapid-pvst timers to a reasonably aggressive value. So not aggressive, but reasonably aggressive. And obviously set your peer link value. I would set the peer link values to be rather aggressive, so not so much that it causes false positives, but aggressive enough that you can kick over as fast as you need to get continuous forwarding. So, and once again, if you wanted to experiment with load balancing, where you know he's root bridge for odd, he's root bridge for even, you can do that. In fact, it's talked about here, but that's, I mean, look at the config. It's ugly. It's hard to follow. It just doesn't. It just doesn't at all look good. So that is that when it comes to this setup. And hopefully this has been informative for you to look at it from this perspective. And if you have any questions, please feel free to post below it. And I hope you've enjoyed watching this. Thank you.